Alright, welcome to this class. In this video, we want to consider one linear, one quadratic simultaneous equations. Usually, at the very foundational level of simultaneous equations, you may be already used to solving two linear simultaneous equations. Let's say you have something like this: plus y equals to 1. And then simultaneously you have to get the value of x and get the value of y. In most cases, the value of x will be 1, just one value, and value of y also will be just one value. But we want to see in this video how a quadratic equation can be combined with a linear equation to be solved simultaneously. So let's start with number 1. Okay, so the questions we have in number 1, we have solve simultaneously equations x squared plus y squared. So we are dealing with number 1 now, equals 13. Okay, and then we have x equals y minus 5. X equals to y minus 5. So obviously this is the quadratic aspect. This is the quadratic equation here, because we can see that the variable or the unknown there has the power of 2. So let's make this equation 1, and then we make this equation 2. So it is a very good culture for you to start with your linear equation. So we can say that from here now, we see that we can substitute y minus 5 for x in equation 1. So we put that to represent x. So why are we doing that? So in other words, we want to make this equation to be homogeneous, that is just to have one variable, so that it will be solvable for us. We can't probably possibly solve it while we have both x and y in the equation. So we can now say that equation 1 now, where we want to substitute y minus 5 for x, we can write it now. So anywhere we have x, we put y minus 5 and square, and then plus this y square plus y square equals 13. And then we can expand this. That will give us y square. Of course, let me expand this with you. Let me assume. So that will be y minus 5, because it's actually square, then plus y square equals 13. And then we can say we have y square times minus 5 will be minus 5y, minus 5y again, then plus 25 plus y square equals 13. And this y square plus this y square will give us 2y square, minus 5y will give us minus 10y. We have plus 25. This 13 here can be brought here, will be minus 13, and then all equals to 0. And then we can say we have 2y square minus 10y plus 12 equals 0. So here now we can factorize out 2, so that we can make the values that we have in this now a quadratic equation, we can make the values smaller. So divide both sides by 2. So that would now be y squared minus 5y plus 6 equals 0. So factorizing this, we see that this can give us y squared minus 3 times 2 will give us 6. 3 plus 2 will definitely give us 5. That's plus 6 equals to 0. I'm factorizing now. Minus 3y minus 2y plus 6. We pair them, and then we have equals to 0. Y is common here, so what will remain is y minus 3, and the minus 2 is common here, what will remain will be y minus 3 then equals to 0. Y minus 3 is common now. This and this will bring it out, and then it will remain y minus 2 equals 0. Y minus 3 equals to 0, or y minus 2 equals to 0. Y equals to 3, or y equals to 2. So now that we have this, we can go back, since we have two values for y now. So we recall that from our second equation, x is equals to y minus 5. So we can say recall that what? X equals to y minus 5. Let's check that again, y minus 5. So when y equals to 3, x will be equals to, instead of y now we put 3 minus 5, x will be equals to minus 2. And the solution here, if you write it as, according to coordinates, that will be x is minus 2 and then y is 3. And then when y equals to the second value, which is what, 2, then we use our equation again, where we have x equals to y minus 5. That will be x equals to, now y is 2 minus 5, x equals to minus 3. So if you write it according to coordinate also, so that will be x is minus 3, y is 2. Therefore, the solutions are, okay, this, that's minus 2 comma 3, and this minus 3 comma 2. So we have gotten the values of y and x, and that's it for number 1. So I hope you have a good understanding of this. In the next video, I will be solving number 2 with you. See you.